Welcome. Have you ever wondered how to build a solution that will enable you to move your factory from its traditionally manual and sometimes paper-based operations to digital and more database operations? In my experience, building a solution like that is no easy task. So in this video, I'm going to show you how to use Microsoft Azure's pre-configured connected factory solution to begin connecting your factory floor devices and equipment in minutes. So let's get started. Hi, I'm Kutsayamandi Teresa and I'll be your host as I show you how to quickly build a connected factory solution using Azure IoT Suite. So here's the thing, if you've ever tried or even thought about developing the required software to securely connect, monitor or even control your factory equipment from the cloud, you'd agree with me that it is a huge task that could take months putting together the architecture and developing the actual software. And what's more is that it will require a cross-functional team to take care of the cloud, security and gateway development. Not to mention the complexities of device connectivity at the plant and also in the cloud. So looking at all of these challenges, it's safe to say that it will be a risky project if you do not have enough resources. However, there are a number of vendors that offer pre-configured solutions to give you a head start. So in essence, a pre-configured solution is when all the necessary elements or components of an end-to-end connected factory architecture are developed, put together into a complete solution which you can then go on to customize to suit your unique scenario. Today, I'm going to take you through one such solution, which is the Microsoft Azure's pre-configured connected factory solution. So we'll start by going through the architectural design of the connected factory to give you a general overview of the solution. After that, we'll take a look at the logical architecture where you get to understand how the actual components of the Azure pre-configured solution come together and how it all works, so you're able to customize it. And then I'll show you how your telemetry data would flow from an OPC US server device on the plant through the gateway and onto your web application in the cloud. And finally, I'll show you how to install the software, configure it, and how to navigate your solution. Let us begin by looking at the general architecture that Microsoft used as the basis of this connected factory solution. So essentially, this solution is about integrating industrial control systems with business systems and the cloud using a common network, right? And right at the edge of that network, we have industrial devices and sensors which come in many different forms. And Microsoft's approach with this connected factory solution was to use OPC UA as the standard for exchanging information both at the plant level and in the cloud. So in a typical scenario, you can use sensors or devices that have an OPC UA server embedded within. And if you've got legacy equipment that talk traditional OPC or classic OPC as it is called, you could use an OPC UA wrapper, right? The role of these endpoints that we're looking at right now is to gather data and when necessary perform some logic and calculations. And what's nice about this pre-configured solution is that it allows us to easily add and remove these endpoints from our solution, as I will show you later on. So please do stick around for that. Now, for us to successfully send data from these plant floor devices to the cloud, we need to have some kind of buffer to handle all the data coming in from the many devices in the plant, or at times multiple plants, right? So this is where the Azure IoT Hub comes in. So this is an Azure endpoint that is deployed in the cloud, and it is a key part of the connected factory solution, as all the information has to go through it. The main purpose of the Azure IoT Hub is to enable reliable and secure communication in both directions that is from the cloud to device and to the device to the cloud. And it also offers device management capabilities. And generally the idea with the IoT Hub is to put data like in a queue. The data that is sent from the plant 4, it is put into a queue, and then this data is made available to data management and some other analytics services in a timely manner. And also each IoT Hub instance can queue up to about 1 million messages, so you're sure not to miss an observation, so to speak. This architecture is put together in such a way that the devices at the edge of the network can actually send JSON payloads directly to the IoT Hub using protocols such as MQTT and AMQP. But more often you find that the plants would have devices or sensors that cannot directly communicate via the internet. Some of them only use two-wire protocols, the likes of RS485. So this calls for the need to use a field gateway to first convert the data coming from the devices into a format such as JSON, and then to send the data to the cloud using internet protocols. And then an approach that I'm also quite excited about is the use of an OPC UA publisher module for handling on-premise device connectivity. So in a typical scenario, this is a software module that is deployed onto a Windows or Linux device running Azure IoT Edge runtime. The concept is based on the OPC UA publish subscribe specification that was introduced by Microsoft to enable uniform distribution of data across devices. So the publisher module includes an OPC UA client for connecting to existing OPC UA servers on the network. So how it would work is that the publisher module would subscribe to the OPC UA servers, which in this case are the devices and sensors at the edge of the network, and the servers send data to the network, and the subscribe client, which is our publisher module, can receive the data and translate the OPC UA data to JSON format, right? The greatest advantage perhaps with this publish subscribe framework for OPC UA is that it can support multiple protocols whilst providing a standard architecture. For example, a machine that talks MQTT can be used to gather data from another one that talks AMQP, for instance. So instead of focusing on protocols, you can actually focus on the information. And the data can be sent directly to the IoT Hub or via the field gateway. And of course, this part that we've covered so far is concerned with the management and connectivity of devices. So now let us turn our attention to the cloud end of our solution. So since we've got this stream of information flowing into the cloud, we need to be able to manipulate this information in such a way that it allows meaningful decisions to be made, right? So in that regard, the cloud platform serves as a collection of components or services for managing the information, right? And these components are managed services that are deployed on the cloud. Okay, now using an OPC UA client deployed on the cloud allows you to visualize and send commands to the plant directly from the cloud, right? In this case, your solution may include an OPC UA proxy module at the edge in order to handle communication and authentication between your cloud-based OPC UA client and your OPC UA devices on the plant floor. And then on the cloud, we also need to have analytics software because we're saying that as it stands, when your devices at the plant generate an alarm or event, a decision and corrective action can only be taken by a person located at the plant. So what we want to achieve with the connected factory solution is a situation where that information from the plant can be shared with the IT systems, right? But more importantly, along the way, we want to be able to perform some analytics on the data in order to enable appropriate decisions and actions to be made at the IT level. So Azure Stream Analytics is one of those in-between analytics software. It processes information on the fly, and to do that, it like sort of acts as a pipe, right, into which data enters, it gets massaged and filtered, and then it comes out at the other end, ready for visualization or storage. Okay, and then finally, the information can be presented to decision makers via websites and mobile services. And when a command is sent using a mobile device, that command must be sent to the appropriate device at the plant for in a secure and reliable manner. Now let us move on to analyzing the logical architecture of this solution. And like I said, this is where we get to see the actual components which Microsoft used in putting together the connected factory pre-configured solution. Now that would enable you to understand how it actually works and how to customize it according to your specific business requirements, right? So this is an implementation of an end-to-end industrial solution that uses simulated industrial devices running OPC UA servers in simulated factory production lines, right? And it provides you with a view of the data from these servers using a cloud service called Azure Time Series Insights. Okay, so what Microsoft did is they created a Linux virtual machine for simulating the connected factory components, and on that virtual machine they host Docker containers for the simulation components to run in, right? And as you can see on the architecture here, we have OPC UA server devices, right? And then Azure IoT Edge runtime, which in your case of a practical application will be deployed on an industrial gateway device or Windows PC or Linux in your plant, right? And on the same virtual machine, we have an OPC UA client simulating the manufacturing execution system. So this solution is two modules deployed on the Azure IoT Edge runtime, right? That is the OPC UA publisher and the proxy modules. So an OPC UA publish subscribe specification described earlier is used to send the telemetry data to the IoT hub in JSON format, right? And in the proxy module, there is an implementation of what is called the service assisted communication, right? Whereby the OPC UA client web application can establish connections with OPC UA servers devices on the plant without requiring open ports on the firewall. So our production line in this simulation manufactures parts, right? And it is composed of an assembly station, a test station, and a packaging station. And the manufacturing execution system monitors each station through OPC UA nodes that are updated by the production line simulation, right? And then the MES also calls OPC UA methods to control the stations and pass the product from station to station. Now the OPC UA publisher module running on our Edge runtime connects to the OPC UA station servers and subscribes to the OPC nodes to be published, right? And as explained earlier, the module then converts the data to JSON format and send it to the IoT hub as publish subscribe messages, and it requires HTTPS port 443 to do that. On the other hand, the OPC UA proxy module also uses outbound port 443 to act as a tunnel of communication for binary command and control messages. Now, when the OPC UA publisher module subscribes to the OPC UA node, it will wait until it detects a change in the value of each node, and only then will it send messages to the IoT hub, right? And then the IoT hub acts as an event source to the uh, Azure time series insights for changes in OPC UA nodes, node values at the plant, right? And Azure time series insights stores the data based on the timestamps, and it maintains it for 30 days, and each record contains the value of the node, the timestamp, the node ID, display name, and even the application URI, right? So you can actually filter using the appropriate parameters. And the IoT Hub, in addition to being used as a secure bi-directional communication channel for the proxy module, it also serves as an identity registry for all the OPC UA publisher and subscribe modules of your solution, right? And then our web app, right, which comprises of an integrated OPC UA client. It provides alerts processing and visualization of the telemetry data. And now, before I show you how to install and navigate the actual solution, let us take a look at how the telemetry data flows from an OPC UA server device up to visualization on your web app, right? So first of all, the OPC UA publisher module reads the required X519 certificates and IoT Hub security credentials from our local certificate store at the edge, as you can see there, and the publisher then registers itself with the IoT Hub using MQTT as a default protocol, right? When the registration is done, the publisher reads the config file and then creates an OPC session with each configured OPC UA server using a TCP connection, right? The publisher and the server, they authenticate each other using the S519 certificates, right? And the publisher creates an OPC subscription and nodes to publish in that subscription. And then, of course, if the node value changes, the OPC UA server sends updates to the publisher. The publisher translates the new value, creates an IoT Hub message, and it sends it to the IoT Hub using MQTT. And then from there, the time series insights reads the message from the IoT Hub using AMQP. It retains the data, and your connected factory web application then queries the required information from the time series insights, right? And then finally, your web browser connects to the connected factory web app over HTTPS and displays the dashboard after authentication, of course. And the web app itself uses Signal R protocol to dynamically update the data on the browser, and that's it. Okay, so to deploy your connected factory solution, you go to Azure IoT Suite.com. Right, you log in. Okay, so I already have an account. So if you do not have an account, you can sign up for a trial version. So when when the page loads, you can create a new solution. And as you can see, there are other types of pre-configured solutions, but our focus today is on the connected factory. So we'll go ahead and select that. Right, and then you can give your selection a name. Select a subscription. Accept, and then you can select your region and then create your solution. So this provisioning process takes a few minutes, so I'll pause the video here. Okay, so the provisioning process is finished and we can launch our solution now. Right, and what we see here is our main dashboard, right? And then if you look here, it will show all of the listed all of the different plants in different geographical areas, right? So it shows us the status of that plant, its location, and the current production. So as you can see here, we've got errors in each and every plant, right? And then here to the right, we have our alarms, and right here at the bottom, we've got the overall equipment efficiency and the key performance indicators for the entire organization. So you can actually drill into a plant, a production line, to find out exactly what's going on in real time, right? And then as you can see here, our production line is a current configuration is the carburetor, and there's an error currently present, right? So you can drill into that production line, and then you can see in real time what's taking place, right? So this is all simulated, but you'll be able to add your own devices to see exactly what's going on in your plant, right? So here we see there is an error here. We can actually drill into this error, right? And then we see that the error here is actually the value that is above maximum. Our pressure value is above the maximum, and the number of products is below the minimum, and our energy consumption is also below the minimum, right? So as you can see, this gives you maximum visibility to what's going on in your plant in real time. And then if we look here at the bottom, we can actually see that our overall efficiency is 86.6%. The availability of our assets is at 100%. The performance at 93.1%. And then our key performance indicators, we can actually see the quality of the products is looking good. And then we're performing poorly with as far as the rate of production, because we're doing like 43 units per hour, which is far below the expected value. And also our energy consumption is below an acceptable value, right? And then when we click on the pressure, we can actually get a glimpse in Azure Time Series Insights of what's been going on in the last hour, and also in the last 24 hours and last 7 days. But of course, this solution it won't be useful to us if we're not able to add devices of our own, as opposed to using the simulated ones. So now let's take a look at the OPC UA devices that are currently connected to this solution. So you can see here we have a list of OPC UA endpoints from simulated devices, and these can be coming from sensors, devices, PLCs, and so on. It could be different platforms, others Linux and Windows and stuff like that. And then here you have the ability to connect your own gateways, right? Now, as you can see, there are instructions for Windows, Linux, and also instructions for editing the assembly line information, right? Now, once you have developed your new device, you can add it to the solution by entering your OPC UA endpoint, server endpoint right here, and then connecting it to the solution. And then you can also download your certificate from here. Okay, so as you can see, this is quite a compelling solution that could really transform the way you do business as a manufacturer, right? And then finally, if you're a developer like myself, you'll be thrilled to find out that the code for all of this is available for free on GitHub, so you can actually customize it to your own unique requirements. Let us quickly take a look at your back end. So if you go to your Microsoft Azure portal, right, and you go under resource groups, right, you would find your connected factory resource group there. So in essence, a resource group is a bundle of components that were used to create that solution, right? So if you open up your resource group, you'll see all the different components that were used to actually put together your solution. So as you can see here, we've got the virtual machine, we've got network interface, we've got our app service, we've got the IoT hub, and we've also got the time series insights, right? And you can actually drill into a component like IoT hub in this instance, and you can see activity, the information to see how many devices are connected to it, and the amount of messages that have been passed so far. And you can also do a lot of configurations with this solution. So that brings us to the end of this video. If you'd like to discuss this topic further, I'd love to hear from you in the comment section below. And if you found this video useful, please subscribe to this channel for more videos, and let's also connect on social media. What I would like to find out from you is if you are or have been involved in developing software to connect industrial equipment to the cloud. What technologies are you using, and is it working for you? Again, let me know in the comment section below. So thanks for watching. See you next week, same time, same place. Goodbye.